When you hit print on your computer, you don't send a list of mechanical coordinates to a printer head. You just ask for a document, and the software translates your request into the chaotic physical process of spraying ink across a page. But if you want to use Ethereum today, you are essentially forced to manually program that printer head. You operate in a strictly imperative system where you have to define the exact step-by-step process of how every action should be executed. This diagram shows the exhausting path a user must take to execute a single trade on Ethereum. You have to locate a specific DEX, a decentralized exchange, which is a peer-to-peer marketplace where transactions occur directly between crypto traders. Then you have to manually set your slippage tolerances, calculate the gas fees required to process the data, and cryptographically sign the exact execution path you want your tokens to take. Because you broadcast your exact route to the public network, your trade is highly vulnerable. Transactions routinely fail, or the trade is intercepted by MEV bots. MEV, or Maximal Extractable Value, refers to automated programs that spot your pending trade and front-run it, extracting your value before your transaction even settles. The crypto industry has spent years trying to solve this friction by building faster blockchains. Developers keep launching new networks that process more transactions per second, but that is the equivalent of building a faster printer when the actual problem is that the user is being forced to write machine code. Anoma's usability barrier is a software problem. Anoma provides the abstraction that has been missing since the beginning, acting as a distributed operating system that manages the network's complexities, rather than just adding more hardware speed. Anoma does not compete with Ethereum for block space or validation. It is a separate layer designed to sit directly on top of the existing network infrastructure. This animated diagram shows how the two systems physically connect through a mechanism called the protocol adapter. The protocol adapter is a smart contract that locks onto the Ethereum mainnet and acts as a universal translator, functioning like a printer driver installed onto a computer motherboard. A smart contract is a self-executing program stored on a blockchain that runs automatically when predetermined conditions are met. Once deployed, this adapter virtualizes Ethereum's state architecture. It allows applications built on Anoma to completely bypass Ethereum's clunky user interface. The Ethereum network is then used strictly as a back-end settlement layer to process the final numbers. By separating the interface from the settlement layer, the user's role shifts. Instead of writing rigid, imperative step-by-step instructions, users simply broadcast declarative intents. An intent is a simple declaration of a desired outcome. It allows you to state that you want to buy token X for price Y, without specifying the route, the liquidity pool, or the computational method required to actually get there. But if you only broadcast an intent, someone else has to perform the complex routing, bridging, and gas calculations to make the trade happen. That work is outsourced to a network of actors known as solvers. This diagram illustrates what is known as the solver industrial complex. Solvers are specialized background processes racing against each other to find the fastest, cheapest execution route for your specific intent. They scan on-chain liquidity, private market makers, and other user intents to map out the optimal path. The solver that constructs the most efficient route wins the right to execute your trade. It takes that optimized path and pushes it through the protocol adapter, where it drops down into the base layer to settle securely on Ethereum. This competitive network of solvers entirely abstracts the mechanics of blockchain execution. You no longer have to program the machine, you finally just get to click print. With the Anoma operating system active, the interface prioritizes the user's goals over the network's mechanics. The complex manual labor of blockchain navigation is replaced by a single, clean layer of interaction. Because the execution is handled by solvers, you gain access to programmable privacy, shielding your financial data from public view. You also unlock fluid cross-chain interoperability, allowing assets and data to move seamlessly between entirely different blockchain networks. You can interact with applications and assets across multiple distinct networks without ever having to manually bridge those assets or switch network settings inside your digital wallet. The operating system handles the state synchronization in the background. In this model, Ethereum succeeds by fading into the background. It becomes a reliable, unseen engine processing the final state, functioning exactly like the microchip inside your laptop. Shifting the burden of routing and execution from the human to the solver network, fulfills the original promise of a functional, decentralized world computer.